Hello, so in this video I want to talk about coding. Now coding is a really useful technique because it makes numbers easier to work with. So let's suppose I have three numbers. Let's suppose I have 10,000, I have 10,002 and I have 10,004, okay? And all I want to do is I just want to get a feel for this data just by taking the average, and I just want to take the variance, and from that I can infer the standard deviation, but I'm not going to bother with that. So I'm just going to work out the average and I'm just going to work out the variance of this data here. Okay, well I can easily work out the average. The average which I'm going to use, by the way, is the mean, because it's the most commonly used one. So the average is the mean, so I just use the special notation for mean, which is x bar. Okay, and remember how I work out the mean. You've been doing this since primary school. I just add these three numbers together. So I've got 10,000 plus 10,002 plus 10,004, and I'm going to divide through by the number which I have. Well, I've got three values in my data set, so I'm going to divide through by 3. Okay, so 10,000 plus 10,002 plus 10,004. Oh, it makes my brain hurt a little bit, but I can do it. So 10,000 plus 10,002 plus 10,004 comes out to be 30,006, and I'm going to divide through by 3. So it's not a difficult sum to work out, but it is still making my brain hurt a little bit. So then I just divide through by 3. Okay, right. So that works out as 10,002. 10,002. So the mean of this data works out to be 10,002. So what I'm now going to do is I'm now going to just plot these values on a data line or a number line. So 10,000 I'm going to plot here. Okay. 10,002 I'm going to plot just a little bit to the right because obviously 10,002 lies there, and 10,004 I'm going to plot that on the number line, so it's just going to be a little bit to the right. Now what I'm going to do, and this is where coding comes in, is I'm just going to literally pick those values up and I'm going to drag them all the way down to 0. So I'm just literally picking them up and making them all down to 0. So literally all I'm doing is just taking 10,000 away from each number. So take 10,000 away from 10,000, take 10,000 away from 10,002, and I'll take 10,000 away from 10,004. And look at the data set which I end up with. So after I take away 10,000, the data set which I end up with is 10,000 take away 10,000 is 0, 10,002 take away 10,000 is 2, and 10,004 take away 10,000 is 4. So this is my new data set, which I think you'll agree is a much nicer data set because it's not using big numbers, particularly when it works out to work out the mean and the variance on this. So let's just work out the mean just for argument's sake. So the mean is x bar. So again, I just add these numbers together, 0 plus 2 plus 4, and I divide through by the number of values which I have, which is 3. That looks far nicer than the 10,000 and whatever ones that I had before. So 0 plus 2 plus 4 just works out to be 6, divide through by 3, so it comes out as 2. Now that was far easier to work out, far nicer to work out. I didn't have to use my brain cells nearly as much. But look, when I used my original data, my mean came out as 10,002. But then after I picked up the data and dragged them down to 0 to make them sort of much nicer values, my mean came out as 2. Now that makes sense if you think about it, because the mean is just simply measuring like the most common or the middle value or the value which best represents that data, right? So the value that best represents that data is normally the value which lies close. So the average should lie close to my original value. So it should lie sort of about there. But then when I came along and I picked those data values up and I dragged them down to 0, I also picked up the mean as well. And I dragged that down to 0 as well. So in order to get my true mean back, I've just got to reverse that process. So in other words, I've just got to take those values and I've got to put them back where they belong. Okay, so the way which I'm going to do that is just simply by adding 10,000. So by adding 10,000, and that will take me back to my original mean. Okay, cool. So I've worked out the average. Okay, now I'm going to see what happens to the variance. So I'm just going to work out the variance of both sets of numbers. So let's first of all work out the variance of my original set of data. So there's lots of different formulas I can use for the variance. I'm just going to use this one. So sum of x squared over n, take away my mean squared. Okay, so first of all, I need to work out the square of each one of these individual values. So 10,000 squared. 10,000 squared works out to be 1 followed by 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. Now this is already looking absolutely nasty, but there we go. It's big numbers. Then I'm going to add that to 10,002 squared. So 10,002 squared works out to be 1. 10,002 squared works out to be 1, 0, 0.0040004. Okay, that's still pretty nasty. Then I'm going to do 10,004 squared. So 10,004 squared works out to be 1,000,800,0016. Okay, and then what I'm going to end up doing is dividing through by the number of values which I've got, so divide through by 3, but then I'm going to have to take away my mean squared. So if I just write down here, to take away my mean squared, what was my mean squared? It's 10,002 squared, which came out to be 1,004, sorry, 1,000,04. 0004. So lots of big zeros and massive numbers going on. But anyway, this is how I work out the variance. So let's just break it up into sections. So let's just work out this numerator first of all. Okay, so that is equal to, so just adding those numbers on the numerator work together, that comes out as 3,001,20020. Got to divide through by 3. Then I've got to take away 1,000,400,000. Oh my word, this is looking nasty because it's just two big numbers, just massive numbers. Right, okay, so let's have a look. So we've got 3,000, whatever that number is there, divided by 3. Divide that by 3, so that comes out as 1,000,400,006 and 2/3. And then I'm going to take away this 1,000,400,004. I'm sure you'll agree these are just ridiculously massive numbers. So I'm going to take away that, so 1,000,400,004. So that comes out as 2 and 2/3. That's taken the mick, quite frankly, because we've gone off into the stratosphere, quite frankly, just by taking these massive numbers, and then we end up with a ridiculously small number at the end. So we end up with a ridiculously small number at the end, and that's the variance. That's just purely how much the data varies. And if you look at these three numbers, they don't vary by that much. You know, they're sort of, you know, they're relatively close to each other. So you know, it makes sense that the variance should be somewhere around 2. So they don't vary a lot. Then what I'm going to do, though, is pick those numbers up, those 10,000, 10,002, 10,004, my original data set, and I'm going to drag it down to 0 to end up with this data set, and I'm going to do exactly the same thing and work out the variance. So remember, the variance is sum of x squared over n minus my mean squared. So I just need to square all these values, so I end up with 0 plus 2 squared is 4, plus 4 squared, which is 16. Got to divide through by the number which I have, which is 3. Take away my mean squared, so my mean was 2, remember, so it's 4. I haven't had to pick up a calculator once yet, just to point that out. So 0 plus 4 plus 16 is 20 over 3. Then I'm going to take away 4, but I'm using fractions. So remember, when I take away fractions, I need to convert this 4 into something over 3. So that's going to be 12 over 3. 20 minus 12 is 8, and then still over 3. So 8 over 3 works out to be 2 and 2/3. I haven't had to pick up a single calculator because the numbers are just so much easier to work with. And if you notice, this number here is exactly the same as the number we worked out here with our original data set. And that makes sense because remember what the variance is saying. The variance is just simply saying how much the numbers vary from the mean. Well, the thing is, when I pick my numbers up and drag them all the way down here, I'm not changing how much they vary from each other. I'm not changing how much they vary from the mean. I'm just picking those numbers up, making them easier to work with. So in other words, what I can conclude is that after coding, the average, because I pick those numbers up and drag them down to, you know, make them nicer, the average does change because I also pick up the mean or the median or the mode, and I drag that down and I change that value as well. But the variance, which just simply measures how much the data varies, doesn't change because no matter what the numbers are, they still vary by the same amounts. So it doesn't change. And coding actually makes numbers just easier to use. So it's a really nice technique.